All right, this is probably the last flipped class you're going to have of the year. We're getting close to the end of the school year. And so Algebra 1, Lesson 13.1, Simplifying Rational Expressions. All right, so a couple chapters ago, we learned how to factor. And at that point, I said to you, hey, factoring is a key thing in the rest of your algebra career. And we saw now in the previous chapter, we used factoring to solve quadratic equations. And it's a big deal in solving second degree and higher equations. Well, we're going to see in chapter 13 that you also have to know how to factor to be able to handle all kinds of rational expressions that are simply fractions, right? How to simplify fractions, we got to factor. Um, Adding fractions, multiplying fractions, dividing fractions. It all involves factoring. And so here we go, lesson 13.1, simplifying rational expressions. All right, first thought here in this. A special situation happens when a variable is located in the denominator. So when a variable is located in the denominator of a fraction, then any value of the variable that results in the denominator being 0, and we've talked about this, um, that's a problem, and I'll show you that in a minute, is called an excluded. Now there's one of those terms that I'm sure you're going to see on your quiz or test, right? Is called an excluded value. So let me just here in the middle give you an example. Let's suppose we had something simplistic like 15 divided by x. 15 divided by x. Now, x is a variable. It can be any value. If it's 15, then the answer is 1. If it's 30, the answer is a half. If it's 5, the answer is 3. However, what happens if it's 0? All right, so again, let me real quick, division. What is division? All right, so let's suppose you had 10 divided by 2. How many 2's can you fit into 10? You can fit 5 2's. Okay. How many 5's can you fit into 10? You can fit 2 5's into 10. Right, that's what division is. All right. How many zeros can you fit into 15? And the answer is infinity, right? Infinity. And again, when you get to calculus, you're going to tell you infinity. Right now, a lot of courses say undefined, no solution. Well, we can't have infinity. Infinity doesn't work in our math. And that is one of the reasons why they say it's undefined, even though the answer is infinity. So we need to avoid infinity in the denominator. So this first section, number 1, we're just looking to figure out values that the variable cannot be. All right? These are values that the variable cannot be. And it's real simplistic. All right, take a look down here. What value of x will make the bottom a 0? And I hope you'll say that a value of 4. So the excluded value is x cannot equal 4. That would answer the question of the excluded value. Now, we didn't solve or simplify the fraction. We simply figured out a value that the variable cannot be. All right, cannot be a 4. Might be anything else, but it cannot be a 4 because that's going to make the denominator 0. Now look at B. What value can n not be? What value can n not be? Now you have to apply something that we learned earlier. If you apply it in this situation, all right, you got an idea? Well, look, all we need to do, obviously this one isn't as easy as A, right? All you got to do is take your denominator, your factors of your denominator, and set each factor equal to 0. It's an ugly equal sign, isn't it? Writing on an electronic tablet. All right, so solve this little equation. Add a positive 7 to both sides. Divide by 2, and you get n equals 7 halves. But really, what I should have done all along is say n cannot equal, right? N cannot equal 2n minus 7 cannot equal 0. Therefore, 2n cannot equal 7. Therefore, n cannot equal 7 halves. Try a few more. Now you see C is a little bit more complicated, but notice the denominator is already factored. And that's important because just remember the 0 product property from last chapter? Look, if this was all that was there, right? If this was all that was there, let me go ahead and set this up here real quickly. Come on, give me my fill. All right, all right, beautiful. No greats, line effects. There we go. All right, took all that time to get that done. Okay, if this was just the problem, and this thing equaled 0, didn't we learn last chapter how to solve this? Okay, so again, for us though, it's cannot equal 0. So for this first term, x cannot equal 0. 3x plus 2 cannot equal 0, right, from the second factor. Let me finish. Move the 2. 3x cannot equal negative 2. Move the 3. X cannot equal negative 2/3. All right, so first thing x can't be. Second thing x can't be. And now let's take our third factor. 2x minus 7 cannot equal 0. All right, so this last one then again, move the 7, right? Add its opposite to both sides. Move the 2. And we end up with x cannot equal 7/2. All right, so the next one. You're looking at the denominator. So again, all our concern is the numerator. I'm going to go back and get rid of the box here. Right? So we're not concerned about the numerators right now. And again, we're not solving these. We're not simplifying them. All we're trying to do right now is make sure that we understand what values the variables cannot be. That's all we're doing. So again, our focus is on the denominator. Go back on that. Our focus is on the denominator. And so with that denominator, we got to look to factor it, right? So go ahead and factor the denominator. Go ahead and pause the video and factor it if you can. All right, hopefully you're back. So hopefully you say x and x for the x squared. On the back, you're looking at a positive 6, but we got to get negative 5. How about negative 3, negative 2, right? Don't forget you're factoring your outers plus your inners has to equal the middle term, all right? Again, just real quick refresher on factoring. Remember, the front terms have to multiply to the front, right? The back terms have to multiply to the back. Negative 2 times negative 3 is positive 6. And lastly, the outers multiplied plus the inners multiplied. When you add up those like terms, they've got to add up to that middle term, right? That's proper factoring. Okay, so that is the proper factorization. So again, from this one, x cannot equal 2. And from this one, x cannot equal 3. All right, and there are your factors. All right, again, we are not solving these. We're not solving them. We're just finding out values that the variable cannot be. All right, let's get down to some reducing. All right, reducing, some called simplifying. How? We've done this before. We've done it with fractions. If you remember way back when we were reducing fractions, I told you, hey, learn how to reduce with the numbers. And if you learn how to reduce with the numbers, when we get more complicated things, you'll be able to reduce them as well. All right, so how did we factor? How did we reduce? We factored the numerator and denominator. Factor the numerator and the denominator. And take your green, and what do you do after that? You divide out the common factors. You divide out the common factors. Okay? So really, with a rational expression, we've got variables involved. The way you're going to reduce is you've got to factor numerator and denominator and divide out the common factors. All right, we got a couple examples here. All right, so look at B here. All right, so at first thought, you might look and say, well, can I divide this 2 into this 10 and get 5? And the answer is no. You can't do that. This goes back to something we've talked about quite a bit. This 2 is tied into this x, which is tied into this negative 8. This is one quantity. And you can't separate that 2 unless you factor it. All right, so you say, what are we supposed to do? All right, factor the numerator, 2 times 5. Factor the common 2 out of the denominator, 2 times x minus 4. Right? First law of factoring, factor out common factors first. Now, when something is multiplied times another quantity, it is now eligible to be reduced with other things multiplied times a quantity. So these 2's divide out, and we have now reduced this, and that's the answer, 5 over x minus 4. All right? Factoring. Look at the second example here to the right, C. All right, when you look at the denominator, what does your brain say? Does your brain say, oh, that's a fill in the blank? Oh, that's a... All right, we've had this on every test so far since we factored, and hopefully you say, oh, that's a difference of 2 squares. Again, we're trying to get factors because it's factors that get divided out. All right, so remember, plus in the middle of one, minus in the middle of the other. Square root of the first goes first. Oh, I lost my plus and minus. That's okay. And square root of the last, keep losing my stuff, goes last. All right, and that is the factoring of that. Now look what you can do. I'm taking the whole quantity, the x minus 3 as a whole. I'm not doing x divided by x. I'm not doing negative 3 divided by negative 3. I'm doing the whole quantity. You should box these in. This is a key concept, and this is a concept that students goof up. It's the whole x minus 3 on the bottom divided into the whole x minus 3 on top. Now, in this case, there's nothing left in the numerator, so you got to leave a 1 there. Because what's anything divided by itself? It's 1. And the final answer is 1 over x plus 3. Now, by the way, if we were looking at excluded values, there'd be some. We'll deal with that on the back. All right, let's do the last couple of examples here. All right, so look at D. Again, if you want to do it yourself, pause the video. If not, I'm just going to go ahead and factor. All right, so I'm going to factor the numerator. Oh, I see a common 2. Let me factor out the common 2, right? So 2 times quantity x minus 3. Denominator, oh, it's a trinomial. I got to factor that by what method? Hopefully you're saying trial and error, right? All right, the fronts have to multiply to the x squared, right? So I'm going to use x times x. And don't forget now the backs have to multiply to a negative 6. But I'm also concerned about the outers plus the inners equaling that negative x. That's what I'm after, right? So that's what I'm thinking through. So how about negative 3 there? What's this going to give me? This is going to give me a negative 3x. That means if I put the positive 2 with a positive 2x, that'll give me what I want, won't it? So then if the 2 goes there, now my inners are positive 2, and doesn't that give you a negative 1x? It does. Okay, so that is the factorization of that. So notice again what I'm going to do. The whole quantity, oh, it just happens to be x minus 3 again. All right, believe me, you can divide more out than x minus 3s. The whole x minus 3 on the bottom with the whole x minus 3 on the top. What's left? A 2 on the top and an x plus 2 on the bottom. Listen now, you cannot do this. You cannot do that. That is not true. Why? Once again, this 2 is tied into the x. They are one thing. If ever you wonder, make yourself up an example. What's actually that? A 2 over 6 or a 1/3, correct? If you do that, do you get 1/3? No, you get 1/4. It doesn't work, all right? If ever you can't remember, make up your own little simple example and see if it works. Do it with numbers. All right, here we are with E. Again, now factoring, right? That's this chapter. Factoring, factoring, factoring. Got to factor all over the place. So again, when I look at E, I say to myself, hey, how do I reduce? I have to factor the numerator and denominator. I divide out the common factors. All right, so pause it if you want to do it on your own. Trinomial on the top, x and x. What do we got here? -4, +2. That gives me a -2x in the middle. All right, that's the top. Bottom, 3x and x. All right, I need a -10 in the middle. 4 and 2. Oh, okay. How about -4 gives me, that's a -12. Plus 2 is a -10. Okay, that's it. All right, so in this one, the x minus 4 on the top and the x minus 4 on the bottom divide out. And what are we left with? X plus 2 on the top and 3x plus 2 on the bottom. Again, you cannot reduce those 2's. All right? That's the answer. Factoring. Factoring. All right, let's put it all together in a couple more examples. Here's the directions. You'll have to do this in your homework tomorrow in class, right? Simplify, leaving your answer in factored form. Also, state any excluded values. You got to do two things. All right, you look at a problem like this and it looks daunting, but it's just factoring. What's the first law of factoring? Man, you cannot forget to factor out common factors first. You cannot. And in both of these, in the top one, I can get a 3x out. What's left? X squared minus 6x plus 3. Oops, plus 5. Much better. Okay, that's the top. I have a common 5x on the bottom, and that leaves me an x squared minus 4x plus 3 on the bottom. All right, now I have to continue factoring. I'm going to go back to the top and do the trinomial. All right, so x and x. Oh, good. -5, -1. That gives me a +5 in the back, but when I do the outers and the inners, I get that -6. Okay, that's the proper factorization of that. On the bottom, let's see if this trinomial factors, x and x. Yeah, how about -3, -1? Again, that's going to give me a +3 in the back. It's going to give me the -4 in the middle with the outers and inners, so that's that. Okay. Now, sometimes more than one factor will factor out, and that's the case here. X on the bottom, x top. Now, notice these x's are out by themselves. They're not tied by addition to anything. Therefore, you can cross them out. You say, what do you mean, Mr. Scarfi? Okay, just pause for a second. Don't do this, but look at this x. That x is tied into that -1. Look at this x. That x is tied into the -5. Look at this x. That x is tied into the -1. Look at this x. That x is tied into the -3. All of those other x's are all tied in. But these front x's are not tied into anything by addition. Therefore, they can be divided out. Now, if the top number, this 3, would have divided with that 5, we would, but they don't. But you can do numbers as well as long as they're out by themselves, not tied into anything with addition. And then if you notice, we also have an x minus 1 on the bottom and an x minus 1 on the top. Final answer for the first part, 3 times the quantity x minus 5 over 5 times the quantity x minus 3. Now let me tell you something. Technically, this isn't the final answer. Technically, the final answer is 3 times x is 3x, and 3 times -5 is -15. 3x minus 15 over 5x minus 15. That's technically the final answer, but factoring is time-consuming. And because it's time-consuming, we're going to allow you to leave your answer in factored form to save you time. We've got to teach you the methods. We've got to test the methods to see if you know how to do them. And if we make you multiply everything out at the end, it's going to take too long, especially when we get into multiplication, division, and addition. So Just leave it in factored form. Now, that's the first part of the question. The second part is any excluded values. Now I'm going to look back at my bottom factors. Because remember, it's when the bottom becomes a 0. So I'm thinking about these before they're crossed out. From this x, x cannot equal 0. From this x minus 1, x cannot equal 1. And from this x minus 3, x cannot equal 3. Again, you're setting each factor equal to 0, solving the little equation. We're doing that in our head. Okay? So those are the two solutions. The one is the simplified rational expression, and the other are the excluded values. X can be anything except 0, 1, or 3. Those are not allowed values because they make the solution infinity. Okay, one more. Last one. This one's not as complex. I figured I'd do the hard one first and show you how to do it. Okay, so we've got to go ahead and factor numerator and denominator. All right, my advice is pause the video, go ahead and do it yourself and see if you got it correct. All right, hopefully you're back. Let's see if we can factor the numerator. Got to use a 2n and an n, right? Because again, we're coming from this 2n squared. So that's got to be a 2n and an n. Okay, and then in the back, we've got a negative 9. So I've got 9 and 1, 3 and 3. You know what? 9, 18, 7, 9. I think it's got to be 3 and 3. So I put the 3 there, and it's a negative 9, so one's negative and one's positive. Okay, so I'm thinking about my outers. Hey, if that's a plus, that's a positive 6x. And then my middles would be a negative 3n, so positive 6n, negative 3n. Hey, that gives me the proper middle, right? And that is the factoring of that. Okay, so I'm going to cross that out. I did factor it. The bottom, hopefully you recognize the difference of two squares. Plus in the middle of one, minus in the middle of the other. Square root of the first goes first, right? 2n, 2n. And don't forget, square root of the last goes last, 3 and 3. All right, we factored that difference, two squares. All right, does anything reduce? Hey, I've got to tell you, sometimes nothing will reduce. But hopefully they will, because that's what we're trying to practice. Those 2n minus 3's are gone. Numerator, n plus 3. Denominator, 2n plus 3. Now remember again, they asked us to do two things. They asked us to simplify the rational expression, and they also asked us to find any excluded values. So again, let me just refresh your memory. You're setting each of these and saying they cannot equal 0. And then you're going to solve the little equation. All right, go back to one on the left. Add a negative 3 to both sides. Divide both sides by 2. N cannot be negative 3/2. The one on the right, add a positive 3 to both sides. Divide both sides by 2. N cannot be 3/2. All right. There's the simplified version, and there are the two excluded values in this problem. Rational expressions, that's what we're talking about. All right, don't worry about your homework. We won't worry about that until tomorrow in class. And again, I think this is your last flipped. You might have opportunity for some review later on, but this is the last time we're going to flip with a lesson. All right, have a great night.